Find the derivative of f of x equals the square root of 4x squared plus 3 divided by 2x minus 1. So f of x here is the quotient of two different functions. We have the square root of 4x squared plus 3 divided by 2x minus 1. We will therefore use the quotient rule. But before I do that, let's rewrite that numerator as a fractional exponent. That's 4x squared plus 3 to the first power second root, so 1/2 power. We'll leave the denominator as is. The derivative f prime of x will start with the quotient rule. The derivative of the numerator, bring the power down, 1/2. Leave the inside alone, 4x squared plus 3. Subtract 1 from the power, I will call that 2/2. But then multiply by the derivative of the inside to complete the chain rule. The derivative of the inside will be an 8x. That's all the derivative of the numerator. Then we have this multiplied with the denominator left alone, minus the numerator left alone, times the derivative of the denominator. Derivative of the denominator is a 2. All of this divided by the denominator quantity squared. Now in the numerator, I'm going to move this 8x out here with this 1/2. It will multiply with it, so it'll be 8x over 2. That 8x is in the numerator. We have a 4x squared plus 3 to the 1 minus 2, negative 1/2. We have a 2x minus 1. And then we have a minus. I'm going to move the 2 to the front of that one, and then the 4x squared plus 3 to the positive 1/2. All this over 2x minus 1 quantity squared. We always want to rewrite negative exponents by moving them to their respective denominator. Now this first term, I'm going to cancel this 8 and this 2 down to leave a 4. So we have the 4x. We also have a 2x minus 1. Those are going to stay in the numerator. But that 4x squared plus 3 to the negative 1/2 will move to its denominator to become a positive exponent. Our next term, we have minus 2 times 4x squared plus 3 to the positive 1/2. And then all of that is over 2x minus 1 quantity squared. What we're going to need to do is combine those terms in the numerator once a fraction, and we need a common denominator. So I have to multiply this other one by 4x squared plus 3 to the 1/2 over itself. To get a common denominator between those terms so that we can combine them, and that means we'll have a 4x times a 2x minus 1, and then minus, notice the minus here, and we have the 2. So minus 2 times, and then these, both in the numerator, can multiply. You add their exponents, 1/2 plus 1/2, which is a 1. So we'll end up with 4x squared plus 3 to the first power. All of this is over that common denominator of 4x squared plus 3 to the 1/2. And then the entire thing is over 2x minus 1 squared. So f prime of x will equal, now let's distribute the 4x in here. We will have 8x squared minus 4x, and we'll distribute the minus 2 into here, minus 8x squared minus 6 all over 4x squared plus 3 to the 1/2. I'm going to rewrite that as square root to the first power. And then all of this over 2x minus 1 quantity squared. Now in the numerator, the 8x squared and the negative 8x squared will be able to cancel each other. And what I'm going to do now is we have a fraction in the numerator and we have a fraction, well, what can be made a fraction anyway. In the denominator, we will reciprocate and multiply. So this is going to become negative 4x minus 6 over the square root of 4x squared plus 3 multiplied with 1 over 2x minus 1 quantity squared. Now if we multiply that numerator times 1, it will stay itself. And then the denominator, we multiply those. I will write the 2x minus 1 quantity squared first, and then the square root of 4x squared plus 3. So there's our derivative. The only other thing that we can maybe do here is factor the numerator. It looks like we have a common factor of maybe a negative 2. And we can say negative 2 times 2x plus 3. Other than that, though, everything else will remain the same. So 2x minus 1 squared and square root of 4x squared plus 3 all in the denominator. And there is our derivative f prime of x.